All right, my friends. So today we actually kind of hit the halfway point of the course, kind of, sort of. I try to design the whole course so that it's the theme is applied arithmetic. But really, today we start getting into the measure of more uncertainty. The things we've been looking at so far, and everything from looking for patterns in data to looking at break-even points for costs and measuring roads. All that has been data analysis in a way, but it's been fairly certain. Like if we know that it takes 5 pounds of calcium hardness increaser to treat 10,000 gallons of water, then we can figure out how many it takes to treat 300 gallons of water. Today we really begin into the look of the uncertain, which is, I like to start with statistics and then move into probability. So we're going to go ahead and look at one of my favorite quotes is, there are lies, there are damned lies, and then there are statistics. And I love that. But what I want you to do right now is take some time, and I want you to actually Google up what is or what are statistics. And I put is or are because statistics itself can be used as a singular noun or also a plural of the noun statistics or statistic. So Google it up, take some time right now, and then we'll regroup and see what you found. Okay, friends, let's see what you came up with. Well, actually, I guess I can't see what you came up with. So let's come up with some stuff together. Let's do a little quick search. The secret life of I wonder how many times I say Google. So we'll look at Happy Earth Day, by the way, if you're watching these on Earth Day. Statistics. Spelled wrong and everything. All right, let's just head down. Statistics is a form of mathematical analysis that uses quantified models, representations, and synopses for a given set of experimental data or real-life studies. It's kind of wordy, but I see what they're getting at. Studies methodologies to gather, review, analyze, and draw conclusions from data. I think that both of those sentences there say the exact same thing. You're drawing conclusions from data. I think we can probably just safely say drawing conclusions from data. Let's look at this Wikipedia entry. Statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. Again, it's about drawing conclusions from data, but also adding something else. Presenting, collecting, organizing, and presenting. I would actually group those three things, collection, organization, and presentation, as one thing, and then analysis and interpretation, or both, as another. Okay. Good. This is going to be way too much detail for us to talk about in this first day, so we're going to back out of this. People also ask, what are examples of statistics? Statistics are defined as numerical data. That's actually not true. And is the field of math that deals with the collect. You know what? I don't like this because they said the first thing was wrong already. What is statistics? The two main types. We don't have to get into that right now. What are basic statistics? Oh, this is not bad actually. The most common basic statistics terms you'll come across are the mean, mode, and median. Okay, good. Okay, so now we up here. Statistics here is that first one I mentioned. It's the branch. It's a plural collective noun, as is this. Statistics is the discipline. Down here, this was the wrong definition, but it said statistics are defined as numerical data. This one here, where was it? What are basic statistics? The most common basic statistics you'll come across are. So the mean is a statistic. The mode is a statistic. Okay, I think we've gotten enough here to kind of put this into, I think we can put this into a collective here. So if we use statistics as that collective, a field of study, the big idea, the first big idea is gathering and displaying information somehow. And I put in parentheses often graphically and tabularly. We'll look at some examples of those today. And the other one is, once you have data collected and you've maybe displayed it, you then infer something about an entire population. So I'm going to break that down for you a little bit. A sample, and we're going to talk more about this on day 2, A sample is just a small subgroup of a larger group that we call a population. So the sample is a small subgroup of a population. You, generally speaking, cannot gather the entire population or cannot measure the entire population. So you collect a sample from that, and you use the information you have from the sample to infer something about the entire population. Okay, well, and we're going to come back to all that. This stuff here, the second bullet is more day 2. This is more day 1. We'll get into that today. Okay, now if you want to talk about statistics or a statistic used as a single measure or a collection of measures, it's a measure of a sample. So once you draw a sample up here, it's one of the ways you measure it. So you might take the average of your sample, or you might take the median of your sample, or maybe you'll take a proportion of your sample that has a certain characteristic. I would like to contrast that for the time being with what's called a parameter. Parameters are the measure of an entire population. So for example, the only parameters that I can really think about that I run into on any given basis are results from the United States Census that happens every 10 years, and maybe some stuff at COCC. Because if I wanted to know, for example, how many students there are at COCC, well, I can actually find that out. And if I want to know what percentage of them live in, say, Madras, I could actually find the exact percentage at any given time because I know exactly how many students live in Madras, and I can divide that by exactly how many students are at COCC overall. Compare and contrast that with something, I'm going to throw an example out here that we'll come back to. Suppose you wanted to know what percentage of community college students in the United States are between the ages of 18 and 24. That would be much harder data to get. So you'd probably just draw samples from selected colleges or randomly selected colleges. Something even harder to get, because if you really wanted to, you could get the parameter version of that too. Something even harder would be, what is the prevalence of, for example, I don't know, ADHD among 16 to 21-year-old males in America? Now, there's something you actually cannot collect directly because you can't actually measure every single 16 to 21-year-old male. So what you do is you grab a sample of them, you measure them in some way, and we'll come back to that next class, and then you form a statistic about that measure. And then hopefully you infer something about that statistic for the population. And we'll get into that, like I said, in day 2. All right, so let's move on to the next video and get deeper into this world of statistics.